This problem is taking a picture of a function f of x and determining which of these x values these things happen at. Now this is pretty far away. It helps to kind of see the graph close up. So let me zoom in a little bit so you can see it better. All right, that looks good. Now let's think about where f of x is less than 0. This is saying, where are my outputs less than 0? Where are my outputs negative? That's how you interpret that. Outputs negative. And it looks like my x-axis is here, so anything below that will be negative outputs. So A would be where x4 and x sub 5 are, all negative outputs. B is f prime less than 0. That means where on f of x are the slope less than 0, or is the slope less than 0? Now if I look at each one of these and I put little slope tangent lines, right, slope marks I call them, or tangent lines right at each point, I'm looking for the ones that have negative slope, the ones that are less than 0. And it looks like that occurs here at x3 and at x4 only. Notice this positive slope, positive slope, positive slope. But negative slopes occur at x3 and x4. C, f of x is decreasing. If f of x is decreasing, notice from here to here, notice what the sign of the slopes are. They're both negative. So this is a tricky question. This B and C is actually asking you the same question. Same question. So where f of x is decreasing, f prime is less than 0. Letter D, f prime is decreasing. So if you look at all the slope marks across the 5 that I've drawn there, it looks like if you take a look at the steepness, I guess, for the lack of a better word, this one is a little less steep than this one. So that means my derivative is increasing there. But notice this one here is positive, and then all of a sudden it becomes negative. Now if I am on a number line and I move from positive values to negative values, that means I'm decreasing. So it looks like f prime is decreasing from x2 to x3. Now from x3 to x4, I'm going from something that's negative to something that's a little less negative, so I'm moving to the right on the number line. And then I'm going from a positive slope to a negative slope to a positive slope, so again I'm continuing to move right. So from here everything starts increasing. So x2 and x3 is where f prime is decreasing. Letter E, slope of f of x is positive. Well, let's just look at the slope marks. Where are the slope marks positive? Looks like x1, x2, and x5. I'm telling you, making those little tiny slope marks makes a difference when you do these problems. And lastly, F, the slope of f of x is increasing. So the slope of f is increasing. So it looks like from x1 to x2, f of x is increasing slightly. Between f4 and f5 it's increasing. But you know, let's think about this for a second. F prime is decreasing. Let's go back to D. F prime is decreasing here where f is concave down. So we can think that the slope of f of x is increasing, which is f prime is increasing. Means that f is concave up there. It's exactly the same thing. So it looks like I'm kind of concave up at x1. I mean, we could say it's either concave up or inflection points, but I'm just going to say it's concave up. And we're concave up where x4 occurs and where x5 occurs. So it looks like those are the places that the particular questions ask me to find in the graph.